Okay, let's go. So I prepared quite some slides. I have quite a lot of things to tell you. I'm very happy that you're all here. So thank you very much. I didn't expect so many people. Normally, I always start with a black slide. And then I ask, what is this black slide doing there? And it's my first picture. It's what an AI model looks like if you are not an AI expert. So my black picture is actually an AI model from the inside. Now, of course, I will have to come here because the pointer doesn't work. And the sliders also don't want to go further. Yeah. Can I try again? And now it works. Okay. So many spoilers. So when we zoom out, this is the AI model from the outside. It's a black box, and we all know that this is the current state of a lot of difficult AI models right now. Something is what we put in, and then some magic happens. There's a lot of calculations, and then something comes out. Like the chick is transformed into the dinosaur, and we don't have a clue why. So there are two options. First one is, maybe you're happy, maybe you like the dinosaur, and then you can go on with your life and you can accept the dinosaur. That's great. But the second option is, what if you're asking, why is there a dinosaur over there? Like, what happened on the inside of this box? I have no clue. I want to know. Well, in that case, we need to do a bit more. In that case, we need to try to unpack what is going on inside. And then we land in this very complex diagram. So there's actually a lot of things going on when we're talking about a model and a person looking at an outcome and trying to make sense of it. So let me walk you through this. So there is some data, that's our chick. We feed into our black box model, and then something comes out, that's a dinosaur, that's a prediction. And then as a target audience, we are asking ourselves, what's going on here? So we try to understand this whole process, the whole machine learning system there. And there are lots of things that we can do to try to get an overview of what is going on. And so this is where XAI, or explainable artificial intelligence, comes in. There are many, many, many possibilities to try to get some understanding of what goes on in this box. So here you see the whole aspect of different possibilities. We can talk about the data, and then we can look at global or local explanations. We can try to look at the model itself with model-focused explanations. We can try to make the model like a glass box model, like something we can understand by just looking at it. Or we can do a post hoc analysis, which means we try to explain what the dinosaur is doing over there and try to catch some justification. And then there is also this side, the target audience, which is quite complicated. We are humans and we are so complex. We want to know different things. We have different values that we find interesting. Maybe we want the outcome to be fair. Maybe we want to understand the causality. Why was there a dinosaur? Maybe we need to interact with the model because maybe we don't want a green dinosaur, but maybe we want a red dinosaur. So there's lots of possibilities. So let's try to unpack this. There are two sides. The first is the algorithmic XAI approaches on the left. And then there's a human-centered XAI approaches on the right. And I'll quickly give you some examples of what you can find in those both sides. So first, the algorithmic XAI approaches. There's actually a ton of techniques that have been developed in the XAI community to try to give some insight. And some insight can be a lot of things. It can be, you see it here, it can be a local explanation, like how does the model behave locally? It can be feature importance, it can be example-based explanations, text-based explanations, and so on and so on. So many things. So for example, local explanations is something you can see here. There are a lot of features. We can try to move the features by changing the values just a little bit and then see how the model behaves. So this is a local explanation in a nice diagram. Then there is feature relevance, or feature importance, as we call it as well. So we want to know which of the features in our training data sets are the most important according to the model. And then, yeah, you can have like a bar chart that says, hey, this is very important, this is not important, those kind of things. We can also have more complex diagrams where For each instance, we do the same thing, and then we plot all the instances, and then you get these quite nice diagrams. These are Lime and Shap. And then a last example that I just wanted to show, model simplification. We can take this black box, which could be like a neural network, very difficult, and we can make like a proxy model for it. For example, rule-based. You know, if this feature is bigger than 5, then it's this class, and otherwise it's this class, etc. And then again, you can make this nice diagram which shows all these rules in like a waterfall diagrams. This is a nice hint. Let's look at the right side, the target audience. So I said people are quite complex. There are so many people, and we are all using AI models in a different way. We have different goals, and we all need some kind of insight, some technique to understand this black box. Like, how do we do that? There's so many possibilities, right? So this is a nice framework, I think, which tries to categorize people like very roughly. So there could be like AI novices, which means probably your grandmother or my mother or my sister. They have no clue what AI is at all. They've never heard from artificial neural network. What is that? No idea. Then there are data experts or also domain experts, really depends on the context. So that could be a doctor, for example, someone who is a layperson concerning AI, but not concerning their domain. I mean, a doctor is an expert in healthcare, right? So they have different needs. And then there's AI experts who, of course, know everything. They know all the details, the technicalities. They are making these models, steering them, improving them. So here you can see that examples, explanations, should have different design strategies to meet the goals of all these different people. For example, if it's going to be about AI novices, it can be, oh, I just need to trust this model. That's it. For a data expert, it could be, oh, I want to tune the model. Like, I want to select the things that I find interesting. And then for an AI expert, they're really like interested in all the technicalities. Give me those parameters. What happens when I start to debug? Like, how is the model behaving? How can I improve it? So also, if we like evaluate these explanations, no matter their format or their representation, we will also need to evaluate them in a different way, obviously. I mean, for the AI novices, is going to be about their mental model, which means their understanding, like their intuition about the model. How does the model behave? Basic understanding. For data experts, is going to be about task performance. Maybe they just want to improve how they achieve their tasks, right? And then obviously for AI experts, they need to know all the details. So how can they get a grip on the fidelity of the model, etc. So what's very interesting here is that we start with an algorithmic approach, and that is what most computer scientists think about when they think about XAI. It's very important. I mean, I'm a mathematician myself. Like, I appreciate this side of XAI. I haven't like developed my own XAI techniques yet, but super important. But on the other hand, now we have this, and this shows that XAI is as much a design strategy as it is an algorithmic strategy. It's very challenging to come up with all these different explanations for all these different people. And that is what the human-computer interaction community is trying to do. Trying to bring in the perspective of humans and not only the mathematics, which is AI, of course, it's mathematics, it's not magic. So let's go back to the slide here. We are now focused on this understandability. How are we going to do this? Because I've been talking for 10 minutes. How? I've been giving some clues. Transformations through visualizations. Yay! Nice pictures, fun. That's why I was too late, because I was having too much fun with the visualizations. So this is where I come up. Actually, the pronunciation of my name was very, very good. So thank you. Jeroen Oge in English is perfect. I'm from Belgium, as Yucheng was saying. I'm from the KU Leuven University, which is like the biggest, oldest university in our country, which is still relatively small compared to universities out here, of course. So I'm like feeling very privileged to be standing here because I'm just from this tiny speck of the world, and now I'm just talking about XAI to you. So thank you for having me. I will talk to you about explainable AI with tailored interactive visualizations, as was announced. What does that mean? I am going to walk you through 3 steps with lots of examples and hopefully lots of inspiration for you to build upon and to reach out to me if you like me. You saw my website as well. You can go there later on. So 3 steps. The first one is going to be visual analytics. And let's see what exists out there. Like I've shown you a couple of examples of these nice visualizations, but what is there else? So actually, this was the start of my PhD, like almost 4 years ago now. I'm feeling so old. I just wanted to know what kind of approaches exist, what have people tried to do in the visualization community, in healthcare in specific. And so I did a systematic review, and I tried to uncover all these different approaches. Some of the slides are missing, but I will get there. Quite a lot of slides are missing, actually. Just going to have a quick look to see. Oh, okay. Weird. Lots of slides are missing. I was actually going to show in detail because I know some of you are interested in healthcare. So pity that my slides are gone. I don't know why. I wanted to zoom in on this image over there. I found 4 categories in which visual analytics approaches can be categorized. First is visualization. So sorry, it's going to be very small, but I will share the slides afterwards. Visualization here means there's a bunch of data. There's a bunch of outcomes of the model and how they relate. How should we represent that? That's a visualization. Basically just showing the data, the behavior of the model. Then there's interaction. Interaction with a visualization. That could be lots of things. It could be like hovering, filtering, linking different parts of the visualization. Again, I will show you this in the bigger slides. Then there's another kind of like interaction, but it's in the way of control. It's called shepherding. It's another way for control over the model. So now it's not about, I want to see the data. Now it's about, I want to control this model and I want to like feedback my domain expertise and see how the model behaves. So I could, for example, tweak some of the parameters in the models and see what happens. And then finally, there's direct explanations. I've actually already shown quite some examples. You could make like this tree visualization that I showed you before, all sorts of direct explanations, what if explanations, those kind of things. And the point is that with all these examples here, there's like proof for a very rich community of visualization and XAI. So there's a big overlap between those two. But it also seems quite complex. I mean, it's pretty hard to see, but these dashboards look pretty complex. So what can we do about this? So I was interested in, okay, now I know all these things. I have seen that there are so many like examples of visualizations. Can I build one myself? Can I draw lessons from healthcare and apply it in agriculture in this case? So the video also automatically started for some reason. You saw that, maybe I can go back and show you again. Here, this is something I made. It's quite simple visual analytics dashboards where there's stock market prices of different products in different countries. And then there's a very simple model that tries to predict the price. And it also shows uncertainty in the predictions through these colored bands, like these areas. And so I wanted to know, like, what is the effect of this uncertainty on people's trust, on their understanding? Do people in agriculture even need these kind of visualizations? Like, what are the goals? What do they want to know? What do they want to learn? And I did 2 studies about this. So I'm not sure whether you're familiar with how HCI research typically works. So like sometimes just chime in a bit there. I did in-depth studies, which means I asked a lot of questions, hard, critical questions to people for 2 hours. Everyone was pretty mad at me. No, that's not true. It was very fun. And I asked them a lot of stuff about how they understand the model when they are using this, how they trust the model when they see the uncertainty, what they want to see, like what are the insights to better understand this prediction model, because yeah, they're just using it and believing me that it's a good one. But like, what do they actually want to know? And one of the first things that I found is There's something really wrong with the slides. Like a lot of things are missing. I don't know why. Because I wanted to show you the outcomes. You saw it in the paper over here. There, that one. You saw those like two pairs of lines, 2 lines at the top, 2 lines at the bottom. That was the trust evolution of participants during the study, which shows that there was a different behavior. And what was actually interesting is that the background of these people was almost similar. They were all experts in data analysis. They had a lot of statistical and AI knowledge. And yet 2 of them trusted the model and 2 did not. And it was quite extreme. You saw like 2 were at the top, 2 were at the bottom. And I was very intrigued by this. I was like, what is going on? Why does this happen? So I did follow-up interviews with more people, and it became a very qualitative research, which means trying to transcribe all these interviews, trying to find all the themes, like what are people saying? Why are they saying it? What is the overlap? What are the differences? And in the end, actually, I came up with 4 main themes that people always brought up. So the first one was about usability. So yeah, how do they understand the visualization? Do they understand the encoding at all? Is the workflow clear? Then there was usefulness and needs, like what do they actually want from this kind of visualization? What are the insights that they want to see? Do they want to compare, for example, different countries or different products, or do they have a need to control the visualization or the model in some way? Then there was model understanding. Yeah, models on the algorithmic level, like do they understand the algorithm behind it by just looking at it? Because I didn't tell them. And do they understand the outcome? So those are 2 different things. And then finally, there was trust. Like, do they trust explanations? Do they trust this model? Like, would they rely on it in like a real case? Like, would they make business decisions, for example, based on these predictions? And when I mapped out all these different themes, I found several links. So for example, there was a need for control. And if they had that control, then they would better understand the model. So there's like a line from need for control to understanding the algorithmic level. And that led to more trust because of model understanding. So it's like this chain of different things, which shows that a lot of things start with the usefulness and the needs, right? A lot of these arrows are starting in the purple box. So that is why I think this study showed that a human-centered approach is very, very important, because if we do not know the needs as like an AI expert, we're just making all these models. Maybe people don't need it at all, and then they will not trust it because they don't understand it, and then they will not adopt it, and they will just not use the model. That's it. Then you did all the hard work for years as an AI expert, and people are just not using your work, which doesn't make sense. Another thing is that I found that based on the experience that people had with AI, they also had different perceptions in terms of what they needed, which makes sense. I mean, an expert needs more insights into the model, the algorithmic model. For example, I saw that most people got a better understanding, like a gradually better mental model. But when it really came to the details, like the 2 people with low experience were not really sure. They weren't really understanding everything as they were supposed to. There's lots of things to unpack there, but that's like the essence that I wanted to underline here. Human-centered approaches make sense. Okay, let's go to the second part, which is about transparency in the sense of justification. So what does that mean? Transparency is a very loaded term. I mean, it could be a lot of things, depending on how you interpret it based on your background. What I mean with transparency here is I try to justify a model outcome. That means I don't want to explain all the details of the model, like no one is interested in the parameters if they're not AI experts. I just want to give them a kind of understanding, a feeling, a justification for certain outcomes. So for example, remember the dinosaur, maybe the justification is dinosaurs are an evolution of chicks. That's an explanation. So probably the model is like showing me the evolution of the chick. Okay, that's a justification. You don't know how it works exactly, but you kind of get it as a non-expert, and that is most important for you. There are two dashboards. I hope I can show you both. No, there's a ton missing. Like this is really, really annoying because I can't show you the whole part here, which is pretty bad. I will just give you this very, very top image. It's actually a very recent work. We will present it in a week time now in Australia at IUI. I did this together with a colleague who was working on healthcare. And so he got a lot of inspiration from my systematic review that I showed you. And he was interested in what kind of explanations do people prefer? Because I told you there are tons of types of examples for explanations, right? It could be a model-centric approach where you try to give a bit more understanding about how the model behaves. It could be an example-based explanation where you say, oh, this is an example. It could be a counterexample. It could be a what-if explanation, like what happens if this changes? And so we try to compare all these different explanations and see what people actually preferred. And I'll just like keep it briefly here. It was a dashboard with multiple explanations. So we had a data-centric explanation with just the raw data, like what is the model trained on. Then there were the what-if explanations. There were what-if explanations and counterfactuals. So quite a lot of things. And we wanted to see what people preferred. And in the end, we found that people actually really appreciated the data-centric explanations combined with all these model-centric explanations. So it means that it's maybe not enough in all cases to just show things about the model. Maybe people also want to see like the real data underlying the model, like what is happening there, what does it look like? And especially the combination by seeing the data and then seeing how the model behaves was very insightful for these people who were, by the way, either patients, so AI novices, or domain experts, nurses in this case. Okay, let's go to the bottom. There I can tell you something. Actually, the rest of the talk will be mainly based on education because I've been working a lot on education. And I just wanted to give you a bit of the background here. Like I started with lots of work on gamification and tailored gamification on a platform for mathematics. So actually I extended this platform and then added like a recommender system for, hey, I think these exercises are interesting for you because it matches your level, those kind of things. And also, of course, the explanations, because I wanted to explain to, these are high school students. I wanted to explain them why they needed to make these suggested exercises and why the model thought that it was good for them. So when I'm talking about this platform, it will all be based on the explanations that I made for this platform. So this is a general idea. There is this platform that I told you. There's a bunch of students with different competency levels. Maybe someone is an expert, the other one is just competent, the other one's a beginner for, I don't know, basic computations or something. We feed in all these students into our recommender system, and then the recommender system suggests a lot of exercise series. So for example, the first one is at the expert level, the second one at competent, and then this one is like a bit harder than beginner. So, okay, sure, why not? So this is like the algorithmic layer in the system. And then there's the XAI layer. And the first thing I wanted to focus on was transparency. We wanted to like explain to the students why do we suggest these exercises. So I will give you, for example, this expert series because, and then some explanation, which will be, of course, a visualization because that is the focus of my research. This is the visualization. The text is in Dutch, so even if you can read it from that far, don't try to, unless you can understand Dutch. I will translate. This is actually the interface that students saw after they made an exercise, and then the system suggested a new exercise. So first there was like a why, which said, we think that this exercise matches your competency level. So that gave us a clue like why or what the model was based on. Then there was the justification that I talked about. So we justified it by looking at the attempts that other students needed. So for example, here it says, we think that you will be able to make this exercise because other students with a similar like background and competency level just needed like 1 or 2 attempts. So you can do it as well. And this also gave insights into the collaborative filtering that was happening in the algorithm. So there were 2 steps. And we tried to explain that in this way. It also looks very simple, right? It's just a bar chart. Why is that? Why isn't it some kind of nice dashboard like the ones that I showed you before, like very complex? It's because it's children. They were like 12, 13, 14 years old. And we designed this, for us, very simple visualization because that was the only thing they needed, they wanted and understood. If we made it more complex, then these children were like, no. So that's why it's just a bar chart. It's not the fancy visualization that I showed you before. But what we wanted to know was, what is the impact on trust? Nope. Again, slides are missing. It's good that I know all the things that I wanted to show you the results, so it's a pity. But I will tell you the results. It's not a visualization, but you can make the picture in your head. We compared this interface with a placebo interface, which was like just a sentence that didn't like give any insights in the model. The sentence was something like, oh, we recommend you this exercise because our algorithm has decided that it fits you. That doesn't tell anything about the algorithm. It just said there was an algorithm. So it was like a fake explanation. And then another interface without an explanation, just here's the next exercise, go ahead. And then we compared these 3 different versions in a controlled randomized study. And we looked at the effects on trust. And that was actually very interesting. I mean, we measure trust in different ways because trust is also like very complex, very overloaded. If we measured it with 1 question, just do you trust it more? Yes, no, etc. There was no difference between the 3 interfaces. Okay, interesting. But we also measured it on multiple aspects because trust has a lot of components. So, for example, the competence of the model, the benevolence of the model, which means, does it want me to improve? It could be a ton of things. Could also be the transparency, do I understand the model? And when we took into account all these different components and like combined them into this trust score, then all of a sudden there was a difference, which was very interesting. Guess which difference it was? The explanation caused an increase in their multidimensional trust. So trust measured with all these different components. Whereas the fake explanation did not show any increase, which is good because it shows that the fake explanation did not mislead these students into like trusting it more, because that was not the point, right? It's good that I didn't trust it. But the visual explanation did increase their trust. And so that's interesting because it shows that probably the visualization has an effect, but it's not like the most important aspect for gaining trust, because remember, the one-dimensional trust didn't change. So it's a more subtle effect, which means that these visual explanations will not change like the trusting behavior of high school students like drastically, but in a more nuanced, in a more subtle way, which means that there's lots of things to explore, like what is the nuance and can we like make it bigger, for example. Okay, let's go to control, the last part. So there's a second aspect that I find very interesting in XAI, and that is control. And control means control over the model. Can I like steer the model in the way that it gives me outcomes that better fit my needs, the things that I'm looking for? Like, how should we make these control mechanisms? What are their effects? And what is the relationship with visualizations in the first place? Because I'm talking about visualizations. So let's have a look at our little diagram from before. So the platform that recommended the exercise series. And the thing that I wanted to do now was I wanted to add control. I wanted to see what if I want other exercises, how can I do that? Like, for example, I want to lower, for example, in the top case, I want to lower the difficulty level. I want to make it the dark green into a lighter green, or the converse, or maybe I don't want to do anything. I mean, that's possible, right? So how do we do that? This is the interface that we designed. It consists of several parts. So the control is actually pretty simple. It's basically just a slider that always appeared after students completed a series of, I think, 2 exercises. So after every 2 exercises, they got to see this. And this was just a slider that said, make it harder, make it easier, or do nothing. And there was like, you know, all these values in between. They could just pick whatever they want. And afterwards, they also saw how this control impacted their level. So this is the level that the system thought that these students had. So, oops, sorry, I'm clicking everywhere. So this, for example, the evolution after the series that they finished. There was a very, very slight increase, but not a lot. And then it all of a sudden jumped up, which means that the students wanted harder exercises. They wanted harder exercises. So the system thought, oh, you have a higher competency level. So this is how we visualize it. Again, it's very simple. It's not a bar chart, but it's a line chart. It's like the 2 basic charts that we have in Excel that we have all used in our life. So again, not very complex, but if you see the design iterations, I will come back to that, hopefully, if I can show it. There's actually a lot of work that comes into this. I mean, it takes months to design such a simple visualization because you need to first understand what people, in this case, again, children, want to see in the first place. Then we make a lot of proposals and then they either like it or don't like it. It can be a lot of things. It can be about the formats. In the beginning, we had like an interactive slider that was like changing with their level. We also had a bar chart which just showed the different heights of the competency. Could be about the colors, could be about the text, could be about a lot of things, right? So it actually takes like a lot of interviews with these children, a lot of design iterations within the team to come up with this, although it really looks very simple. And then, yeah, this is something I didn't mention, but this was just like, what is my initial level? When students started using the platform, they could like give a rough score of this is what I think my master level is like. So once again, we wanted to know what the impact was on trust. And again, we compared lots of things. We again had a version without any control. We had a version with the slider, but nothing else. And then we also had a version with the slider and the visualization so that we could see what the impact of the visualization itself was without the control. And again, we measured in multiple ways, and I will present this work also at IOI in a week time. So yeah, you get like the spoilers. The outcome here was if we gave students a control, their trust didn't increase, like no matter how we measured it, which was very surprising to us because like one of the foundations of XAI is control over the model, etc., etc., etc. But when we added the visualization, so when we visualized the impact of their control, then all of a sudden there was like a huge increase. It was actually like a full point on a scale from 1 to 7, which is a big jump in our field. And so we were wondering like, hey, this is quite interesting. It shows that if we just add the control mechanism, it's not enough to increase trust of students. But only when they see the impacts of their control, then it has the effect that we like desired in some way, because that was the point of our study. And I mean, we have a lot of hypotheses on why this is, but probably it has a lot to do with the visualization showing something about the behavior of the model. Like people saw this every 2 exercises, as I said, so they saw it quite frequently. And so our our hypothesis about this is that this visualization shows the behavior of the model. So in some way, it's actually an explanation of model behavior. One of the examples that I showed before. So that is what we expect, what we think. But of course, like we haven't analyzed this because it was just a first study. But so lots of questions remaining, and I think it shows the importance of visualizing the impact of a control mechanism here. And then I think I can go back to this slide for the last time, because now I talked about transparency and a justification, and I also talked about a control mechanism. And then the obvious question is, how do we combine both of them? How can we both give like a mechanism to students saying, hey, I want other exercises, and at the same time try to get insights in why these exercises. So yeah, you could say maybe we can just combine the two systems, but we wanted like a single interface. So how do we do that? Nice challenge. Oh, so I wanted to show you the iterations here. But yeah, I'll just show you the end results since that is what the slides decided for us. It's a black box. I have no idea why. I need an explanation later on. So this is the interface in the end that we created. So it's the slider that you saw from before. And then there's this what if explanation. So before students started these exercise series, they could change the difficulty level that they wanted. We also made it a bit more granular than before because yeah, we saw that students wanted that. And then based on whether they made it easier or harder, we showed what the impact would be if they would solve all the exercises correctly. So you saw that if they made it very hard, then it went up. And then if they didn't do anything or they made it easier, yeah, of course, it meant that their level would just stay the same, because if you make everything correctly, then you can't drop, but you wouldn't increase either because it was too easy. So that was our intention. Like, we want to show a what if analysis here. It jumps up just a tiny bit because this was like the first exercise that anyone made here. So it's very subtle here, but other examples were a bit more extreme sometimes. And then we compared it with this interface, which is different. It's a textual interface. There is no visualization all of a sudden. Again, this is in Dutch, so it's hard for you. But what we wanted to do was, we also wanted to study the motivational aspects of an explanation. So not just, oh, I have better understanding, I trust it more, etc. But also, does it motivate me to make these exercises? Because that's pretty important in education, right? And so this was just like a sentence that says, hey, we believe that you have the capacities to solve this exercise. If it was too hard, then it said like a warning, like, hey, don't make it too hard on yourself. If you really want to try it, then go ahead. But know that we think it's probably a bit challenging. And then again, we compared. Again, I'm going to tell you quickly. This is, by the way, not published, so it's like the biggest spoiler of the day. What happened here is a bit tricky. I mean, we didn't find any impact on trust. We didn't find any impact on the critical behavior of students towards themselves and their learning methods. We also didn't find any difference in understanding of the model or self-claimed understanding. Yeah, and also no motivational difference. So yeah, we were like, oops, that is pretty annoying. Like, we wanted to make something that helped students, and it seems that in our experiment, it didn't help them in some way. But again, yeah, I wanted you to show you like the raw data underneath, because we logged like all their behavior with the sliders and everything. And it was a very interesting insight. Like, I can't show it, but I'll make the visualization in the air and then I'll explain it. So we looked at this control mechanism, and we looked at which of the values that they chose. So values between 0 and 1, from easy to very hard. And in these different groups, we looked at the behavior, and we saw that, yeah, as you would expect, with like a very normal distribution, like most of the people didn't change anything. Some made it a bit easier, some made it a bit higher, but like no big changes. Then we had the what if analysis, which was interesting because all of a sudden the people that made it a bit harder were a bit more, like there were more people making it a bit harder for themselves. There was a small shift towards the left. Right for you, sorry, to the right. So a shift towards a bit harder, although it was not statistically significant, we just saw it on the plot. And then the most interesting thing is with the wise feedback, there was the biggest change. Like, there was like twice as many people like were going for the very hard exercises, twice as few people were going for the easy exercises. So a quite big change there. So we are analyzing this at the moment because, yeah, we're like asking ourselves, since we didn't find like a significant overall effect, is there something going on these sides? Because it's pretty clear in the plots that something is going on, but like why? What is the relationship with the level that they had at the moment? Maybe it's related to whether they solved the exercises correctly or not. So there's a lot of things going on. I had another plot that I will share with you afterwards. And then I think the last thing for now is this. I've talked a lot about students, which are the AI novices. In the beginning, I talked about the AI experts and like the medical domain experts. So there's something missing. There's also in education experts, which are teachers. And we're also doing currently research with teachers, like what kind of explanations do they want? And in this case, it was about a completely different system, like nothing to do with recommending exercises. It was about creating exercises. In this case, it was multiple choice questions. So we just worked together with another university in Belgium. They created an algorithm that generated distractors based on a question and the correct answer. So for example, hey, what is the capital of I don't know what? They generated a bunch of distractors. So for example, other cities, sometimes they were good distractors, sometimes they were just bad. Like, what is the capital distractor? Dinosaur. Yeah, that didn't make any sense. And so we wanted to see how people, teachers in this case, reacted to this, what kind of explanations they wanted. Do they want control over the distractors? Do they want to get a visualization of why they got these distractors? And so again, in a kind of qualitative way, we try to analyze through interviews what teachers actually wanted. And again, we are analyzing this at the moment, but I think it's nice to show that there's actually room for a lot of new things to explore. And I think this is where I will end. Let's like wrap up, and you will get all the slides with lots of more examples of the visualizations that you were now missing. We talked first about the visual analytics approaches, so the difficult, like impressive dashboards with lots of things going on, lots of like control. But remember, this is not for AI novices. This is for domain experts, and this is for AI experts. Then I talked about justification in transparency. There we investigated things with domain experts and AI novices. I think the clue here is you need a human-centered approach, right, to come up with these very simple visualizations, because they seem very simple, but it takes a lot of time to design them to make sure that this is what people actually need. And I also showed that with these good designs, we can impact trust, which is what we in the end want, because trust leads to adoption, and adoption means people are using our system. So that's great for us computer scientists. And then finally, I talked about control. So there's transparency and justification, but there is also, I want control over the model, over the outcomes. I want to match them better with the needs that I have, for example. And I showed you different ways to do that. I mean, it was quite easy in this case because it was for students. But in the case of teachers, for example, I mean, you can come up with quite more complex ways to interact with a model, right? So I think that is it. I hope you weren't too disappointed by missing at least 15 minutes because of me being late. If you have any more questions, of course, you can ask them now quickly, depending on how much time we still have. But also reach out, like there is a website with lots of information about the details. You can find all the papers. Also check out the work that we are doing. This is my promoter, Catherine Verbert. This is the website of our group. We're quite small now, but we used to have a lot more people at the time that Yucheng was at our place. There's lots of demos of our work. We work on lots of things apart from XAI and visualizations in lots of application domains. So also take a look there. And thank you very much for having me.